All right, let's go. Number 10. The Dickinsonia fossil. In 2018, a team of researchers led by Australian National University paleobiologist Jochen Brox announced something that pushed the origin of animal life on Earth back into a world no human eye was ever meant to see. The fossil they were studying had been pulled from the remote Ediacara Hills of South Australia, a region of sun-baked sandstone where the ground itself is older than complex life. They had extracted cholesterol molecules from the fossilized tissue, ancient lipids, biological fingerprints. The chemistry left behind when something that was once alive becomes stone. The result was unambiguous. Dickinsonia was an animal, the oldest one ever confirmed, 558 million years old. To grasp what that number means requires letting go of every frame of reference that human history provides. Dickinsonia lived 558 million years ago. The dinosaurs would not appear for another 320 million years. The first plants would not colonize land for another 90 million. The Cambrian explosion, the event that produced nearly every animal body plan still in use today, was still 20 million years in the future. Dickinsonia existed in a world without predators, without skeletons, without teeth. A world where the seafloor was carpeted in microbial mats, and the oceans had only just begun to fill with enough oxygen to sustain creatures larger than a single cell. And Dickinsonia was not small. The specimens recovered from the Ediacara Hills stretch up to 4.5 feet long. Yet, they were only millimeters thick. A flat, oval, rib-segmented organism pressed into the ancient seabed like a quilted bath mat, or a giant fingerprint left by something the Earth has since forgotten. No mouth, no gut, no anus, no eyes, no limbs, just a soft, segmented body absorbing nutrients directly from the microbial film beneath it, drifting or anchoring on a seafloor that no vertebrate eye would witness for hundreds of millions of years. For decades, paleontologists could not agree on what Dickinsonia was. A fungus, a lichen, a failed evolutionary experiment that left no descendants. The fossils were so strange, so unlike anything alive today, that the entire Ediacaran biota, the assemblage of creatures Dickinsonia belonged to, was treated as a kind of biological anomaly. A lost world. An evolutionary draft that nature had thrown away before producing the animals we recognize. But here's where the discovery becomes genuinely disturbing. The cholesterol signature changed everything. Cholesterol is produced by animals, not fungi, not lichens, not bacterial mats. The molecules locked inside that 558 million-year-old fossil were the chemical residue of an animal that had been alive when the continents were unrecognizable, when the atmosphere was thinner, when nothing with a backbone existed anywhere on Earth. The implication is staggering. Complex animal life did not erupt suddenly during the Cambrian. It had already been here, drifting across the seafloor in forms so alien that paleontologists could not even recognize them as relatives. An entire ecosystem of soft, ribbed, segmented organisms had ruled the oceans for tens of millions of years before the ancestors of fish, insects, and mammals ever appeared. They left no skeletons. They left no shells. They left only impressions in the sand and faint molecular ghosts inside the rock. Whatever Dickinsonia was, it was an animal. It was here first. And the world it inhabited, a silent, oxygen-poor sea ruled by creatures that resembled nothing alive today, is a chapter of Earth's history we are only beginning to read. Number 9. The Bluefish Caves. In 2017, archaeologists Lauriane Bourgeon, Ariane Burke, and Thomas Hyam at the University of Montreal published a study in the journal PLOS ONE that quietly detonated one of the most stubborn timelines in North American archaeology. Their subject was not a new excavation. It was a box of bones. Bones that had been sitting in storage for nearly 3 decades, recovered from a series of small caves in the northern Yukon, dismissed by mainstream science and largely forgotten. When the team re-examined them under modern microscopes and with refined radiocarbon techniques, the bones began to speak. And what they said was that humans had been in the Americas at least 24,000 years ago. The Bluefish Caves themselves are unremarkable to the eye. 3 tiny frigid openings carved into a limestone ridge in the Yukon, each barely large enough to crawl into, overlooking a vast subarctic tundra that stretches in every direction toward the horizon. There are no monuments here, no painted walls, no carved pillars, only stone, wind, and the bones of animals that died in the last ice age. Horse, mammoth, caribou, piled in the cold dark where the cave floors meet the rock. But the bones were not simply piled. They had been worked. Under magnification, the team identified fine parallel cut marks scored into yellowed, fractured mammoth ribs. Clean, deliberate, repetitive incisions, consistent with the action of stone tools slicing meat from bone. Horse mandibles showed the same patterning. Caribou long bones bore the unmistakable signatures of butchery, the kind of marks that only form when a hand grips a blade and pulls it with purpose. These were not the gnawings of wolves or the scrape of frost. They were the residue of a meal prepared by people whose existence the textbooks had refused to acknowledge. The numbers behind the discovery are what make it staggering. For most of the 20th century, the accepted date for human arrival in the Americas was approximately 13,000 years ago, tied to the spear points and campsites of the Clovis culture in what is now the American Southwest. The Clovis first model was so entrenched that contrary evidence was routinely shelved, ignored, or attacked. The Bluefish bones had originally been excavated by archaeologist Jacques Cinq-Mars between 1977 and 1987. He had argued from the beginning that they pushed the human timeline back to nearly 24,000 years. The field largely refused to listen. His career suffered for it. The 2017 reanalysis vindicated him in a single paper. The radiocarbon dates held. The cut marks were genuine. The youngest butchered bones came in around 12,000 years ago. The oldest reached back at least 24,000. Human beings had been in the high Yukon, slaughtering horses and mammoths inside caves the size of a closet, during the absolute maximum of the last ice age, when much of North America was still locked beneath continental glaciers. The implications fractured the field. If people were in the Yukon 24,000 years ago, then the standard story of a single migration across the Bering Land Bridge at the end of the Ice Age collapses. The corridor between the ice sheets that supposedly funneled the first Americans southward did not yet exist. The route was sealed, which means the humans who butchered those mammoths arrived earlier, by means that mainstream archaeology had not seriously considered. Some by sea, perhaps, along a kelp-rich Pacific coastline, now drowned. Some perhaps lingering in pockets of unglaciated refuge for thousands of years. The debate over how they arrived and who they were has not been resolved. It is still moving. What unsettles most is the quiet of it. No monuments, no grave goods, no name. Only a handful of cut marks on yellowed mammoth bone, made by someone who knelt in a cold cave at the edge of a frozen world more than 20,000 years ago, and worked in silence. Whoever they were not supposed to be there. And yet they were. And they were not alone in the prehistoric world. Number 8. Homo floresiensis, the hobbit that should not have existed. In 2003, an Australian-Indonesian team led by archaeologist Mike Morwood entered a limestone cave called Liang Bua on the island of Flores in eastern Indonesia and began digging into the cool earthen floor. They were not looking for a new human species. They were looking for evidence of how modern humans had migrated through the Indonesian archipelago tens of thousands of years ago. 6 meters down, the trowels struck bone. What they pulled from the soil was so small that the excavators initially assumed they had found a child. They had not. The skeleton was an adult female. She had stood approximately 3.5 feet tall. Her brain, measured from the volume of her intact skull, was the size of a grapefruit, roughly 400 cubic centimeters, about a third of the volume of a modern human brain, about the same size as the brain of a chimpanzee. She had lived approximately 50,000 years ago. The implications detonated through the field of paleoanthropology before the bones had finished being cataloged. A separate human species, anatomically distinct from Homo sapiens, distinct from Neanderthals, distinct from every hominin then known, had been living on a tropical Indonesian island within the same window of time that modern humans were painting the walls of European caves. She was not an ancestor. She was a contemporary, a neighbor, another kind of person sharing the planet with our own. The team named her species Homo floresiensis. The press named her the Hobbit. The bones that emerged from Liang Bua over the following excavations told a stranger and stranger story. The skeletons were not just small. They were structurally peculiar. The feet were disproportionately large for the body, almost comically so, suggesting a gait unlike anything in the modern human family. The wrists retained primitive features more reminiscent of Australopithecines than of any recent hominin. The jaw lacked a chin. The skull, despite its tiny brain case, sat atop a body that had hunted, butchered, and survived in a tropical environment teeming with predators for tens of thousands of years. And here is where the standard model of human intelligence begins to collapse. The soil layers around the bones contained stone tools, not crude scrapers, sophisticated implements, blades, points, perforators, the kind of refined toolkit that the textbooks had long insisted required a brain at least twice the size of what Homo floresiensis possessed. The same layers contained the butchered remains of Stegodon, a genus of dwarf elephant that had evolved on Flores in isolation. The hobbits had hunted them, coordinated, planned, killed animals many times their own body weight with weapons they had designed and manufactured. There is evidence of fire. There is evidence of repeated, organized return to the same cave across deep stretches of time. A creature with a brain the size of a grapefruit was doing the things our species had claimed as proof of its uniqueness. The doctrine that intelligence scales with brain volume, that sophistication requires the cranial architecture of Homo sapiens, that the great cognitive leap forward was a privilege of our particular lineage, had been quietly disassembled by a 3.5-foot tall woman buried in the floor of an Indonesian cave. Whatever Homo floresiensis was doing inside that small skull, it was not what the models predicted. It was not what the models permitted. The dating is what makes the discovery genuinely disturbing. 50,000 years ago is not deep prehistory. 50,000 years ago, modern humans were already moving through Southeast Asia. Our ancestors and the hobbits almost certainly knew each other existed. They may have seen each other across a beach, across a forest clearing, across the smoke of separate fires. And then the hobbits vanished. Whether by climate, by volcanic eruption, by competition, by something we did, the record falls silent shortly after our arrival on the island. For nearly 1 million years, a separate kind of human had lived on Flores, hunted, made tools, buried their dead in the same cool earthen chambers where the first excavators would eventually find them. An entire parallel humanity, intelligent by every meaningful measure, ended within the lifetime of the species that found their bones. The cave is still there, the floor is still cool, and we still do not know what they thought about us. Number 7. The Sima de los Huesos, the pit of bones that may hold humanity's oldest grave. In the limestone heart of the Atapuerca Mountains in northern Spain, deep within a cave system that twists through the bedrock for kilometers, there is a hole in the floor. Not a passage, not a tunnel. A vertical shaft dropping 43 feet straight down into darkness. At the bottom of that shaft, in a chamber that has known no natural light for nearly 500,000 years, lies a tangle of human bones so dense, so deliberately concentrated, that it defies every conventional explanation for how it got there. The site is called the Sima de los Huesos, Spanish for the pit of bones. The name is functional. It is also, in its quiet way, devastating. Excavations beginning in earnest in the 1980s have recovered the partial remains of at least 28 individuals from the floor of that chamber. Men, women, adolescents, children, skulls, jaws, vertebrae, finger bones, foot bones, entire skeletons fragmented and intermingled in a jumbled mass on the cave floor. The bones date to approximately 430,000 years ago, placing them in a window of human prehistory so remote that Homo sapiens did not yet exist as a species. These were not us. They were something earlier, something ancestral, members of a population now generally classified as early Neanderthals, or their immediate predecessors. The numbers themselves are staggering. 28 individuals in a single chamber, accessible only through a 43-foot vertical drop. No other animal remains dominate the deposit. No evidence of cave bear denning that would explain accidental falls. No water channel that could have washed bodies in from elsewhere. The bones did not arrive at the bottom of that shaft by accident. Something or someone put them there. In 2013, researchers led by Matthias Meyer at the Max Planck Institute for Evolutionary Anthropology in Leipzig accomplished what had been considered impossible. They extracted and sequenced mitochondrial DNA from a femur recovered from the pit, the oldest human DNA ever recovered at that time. Genetic material preserved across 400 millennia inside the cool, stable darkness of a Spanish cave. The results complicated the family tree in ways geneticists are still untangling, but the achievement itself was a revelation. The pit was not just a grave, it was an archive. But here's where the discovery becomes genuinely disturbing. Among the bones, the excavators found a single stone tool. One, a hand axe, beautifully worked, lying in the deposit alongside the human remains. The axe has been nicknamed Excalibur, and the nickname is earned. It is carved from rose-colored quartzite, a material that appears nowhere else in the assemblage of tools from Atapuerca. Every other implement recovered from the surrounding sites is made from local flint or chert in mundane gray and brown. Excalibur is different. Excalibur was chosen. Its presence in the pit cannot be explained as discard. A 43-foot vertical shaft is not a refuse heap. Someone carried that axe to the edge of the drop and let it fall, or climbed down with it and placed it among the dead. The interpretation that has emerged, cautiously, carefully, across decades of analysis, is that Excalibur is an offering, a grave good, the earliest known evidence of ritual burial in the human lineage. Let that settle. 430,000 years ago, hundreds of thousands of years before behavioral modernity is supposed to have emerged, before language is supposed to have stabilized, before symbolic thought is supposed to have existed in any recognizable form, someone climbed down into a black pit with a rose-colored stone and laid it among their dead. The implications dismantle the standard timeline of cognitive evolution. Symbolic thought was not supposed to exist this early. Ritual was not supposed to exist this early. The capacity to look at a dead body and feel that it required something, an object, a gesture, a marker of meaning, was thought to belong to a much later chapter of our story. The Cima de los Huesos suggests that chapter began nearly 500,000 years ago, in the dark, at the bottom of a shaft, in the hands of people whose names and faces are gone forever. The bones are still there. Excalibur is still there. The pit has been mapped, excavated, photographed, and analyzed, but the act that filled it remains beyond reach. Whoever they were, whatever they believed, they left us a single rose-colored stone and walked back up into a world we will never see. Number 6. The Cheddar Man, the face that wasn't supposed to exist. In 1903, workers digging a drainage trench inside Gough's Cave in the Cheddar Gorge of Somerset, England, struck bone. Not the scattered animal remains common to British cave excavations, but a complete human skeleton, curled on its side in the cold limestone darkness, surrounded by the slow drip of stalactites and the calcified breath of 10,000 years of mineral water. The body had been waiting there since the end of the last ice age. It would become the oldest complete human skeleton ever recovered in Britain, and for over a century, no one would understand what it actually was. The man was small, roughly 5 feet 5 inches, lightly built, his bones telling the story of a Mesolithic hunter who had walked the post-glacial forests of southwestern England when Britain was still attached to continental Europe by a sinking land bridge. He had died sometime around 8000 BC, possibly violently, possibly young. His skeleton was placed in the Natural History Museum in London, catalogued, photographed, and for most of the 20th century, treated as a curiosity. Britain's first Briton, a relic from the dawn of the island's human story. For decades, museum reconstructions gave him the face everyone expected: pale skin, light hair, the familiar features of a Northern European, projected backward into prehistory, because no one thought to question whether the assumption was true. He was a founder. He looked like the descendants who would build the villages, the towns, the cathedrals. The continuity seemed self-evident. But here's where the standard explanation falls apart. In 2018, a team from the Natural History Museum and University College London extracted DNA from the dense petrous bone of Cheddar Man's inner ear, one of the few skeletal structures that preserves genetic material across 10 millennia. The sequencing was the most complete ever performed on an ancient British individual. When the genetic markers for pigmentation came back, the results dismantled a century of assumption in a single afternoon. Cheddar Man had dark to black skin. He had dark, tightly curled hair, and set into that face were striking pale blue eyes. The combination didn't match anything the public imagination had constructed for ancient Europe. It also didn't match the museum's own reconstructions. A new bust was commissioned, built from the actual genetic data rather than the inherited assumption, and the face that emerged was unrecognizable from the one Britain had been shown for generations. The first complete Briton looked nothing like the Britons who had claimed him. The implications cascaded outward. Pale skin in Europe, long assumed to be ancient, deeply rooted, fundamental to the continent's identity, was revealed to be a relatively recent adaptation. The genetic shift toward lighter pigmentation didn't sweep across Europe until thousands of years after Cheddar Man died, driven by agricultural diets low in vitamin D and the slow pressure of high-latitude sunlight on populations that had abandoned the hunter-gatherer way of life. For the entire Mesolithic period, the people of Britain, France, Spain, and the broader European landmass looked nothing like the populations that would later occupy those same valleys. And the most unsettling detail came from a separate strand of the analysis. Cheddar Man's descendants are still there. Genetic testing of modern residents of the Cheddar region identified living individuals who share a direct maternal lineage with the 10,000-year-old skeleton. A history teacher in the local village carries the same mitochondrial DNA as the dark-skinned, blue-eyed man pulled from the cave floor a century earlier. The bloodline never left. Only the appearance did. He is still there in his climate-controlled case in London, the small bones of a man who lived before agriculture, before pottery, before the cathedrals that would rise over his homeland. The first Briton. A face the island had to be shown twice before it was willing to look. Number 5. Nigerasaurus, the dinosaur with a skull made of light. In 1999, paleontologist Paul Sereno led an expedition into the Sahara Desert, into a region of Niger so remote that the supply lines stretched for hundreds of kilometers across burning sand. What his team pulled from the bedrock that season would force paleontologists to redraw their assumptions about what dinosaurs were capable of becoming. Embedded in 110-million-year-old sandstone were the fragmented remains of a sauropod unlike anything previously cataloged. The skull alone, once reconstructed, would become one of the most discussed specimens in modern paleontology. Not because of its size, because of what it revealed about the architecture of life on a planet we no longer recognize. The creature stretched roughly 30 feet from snout to tail. By sauropod standards, this was modest. Some of its cousins reached lengths exceeding 100 feet and weights approaching 70 tons. Nigerasaurus was small, almost graceful, a long-necked herbivore moving in herds across the river plains of what was then a lush, swampy floodplain at the edge of an ancient sea. The Sahara had not yet been imagined. The continent itself was still pulling apart from the supercontinent that would become South America. And grazing along those vanished waterways was an animal whose head defied every expectation of what a dinosaur skull should be. The numbers are difficult to absorb. Over 500 teeth, packed into a single mouth. Not arranged for tearing, not arranged for crushing. Arranged in tight parallel rows along a wide, straight-edged muzzle. That resembled nothing so much as the front of a lawnmower. The teeth formed a continuous cutting surface, a biological blade designed to mow vegetation at ground level with mechanical precision. And the entire system was disposable. Sereno's team determined that Nigerasaurus replaced every single tooth in its mouth every 14 days. A complete dental turnover, twice a month, for the duration of its life. The animal was essentially walking through the Cretaceous shedding teeth, the way other creatures shed skin. But here's where the discovery becomes genuinely disturbing. When Sereno's team examined the skull in detail, they discovered that the bones were so thin, so delicately constructed, that light could pass through them. The cranial vault was a translucent shell. The pale, almost ghostly bone was thinner in places than a sheet of paper, and yet it had supported a feeding apparatus operating under constant mechanical stress for the entire life of the animal. The skull was simultaneously one of the most specialized and one of the most fragile structures ever evolved by a vertebrate. Sereno described holding the reconstructed bones up to the sun and watching daylight pour through them. A 110-million-year-old skull that behaved like stained glass. The implications for paleontology were immediate. For most of the 20th century, dinosaurs had been imagined as variations on familiar themes. Larger predators, larger herbivores, bigger teeth, longer necks. The mental model was one of scale, not strangeness. Nigerasaurus shattered that framework. Here was an animal that had evolved into a feeding machine so specialized, so committed to a single ecological function, that its skull had been reduced to the bare minimum of bone required to hold its conveyor belt of teeth in place. It was not a larger version of anything alive today. It was an evolutionary direction that has no modern equivalent. Nothing on Earth currently chews this way. Nothing currently grows and discards teeth at this rate. Nothing currently carries a translucent skull through the world. And this was only one animal, from one site, from one moment in a single ancient river system. The Cretaceous lasted nearly 80 million years. The Sahara has been excavated only in scattered patches. The fossil record represents an almost incomprehensibly thin sampling of what existed. If Nigerasaurus is what the desert happened to preserve from a single floodplain, the question becomes unavoidable. What else walked those riverbanks? What other architectures of bone and tooth and skin evolved, flourished, and vanished without leaving a single fragment for us to find? The truly unsettling aspect is the silence that surrounds the specimen. Nigerasaurus was not an aberration. It was a successful animal, well adapted to its niche, part of a stable ecosystem that persisted for millions of years. It was normal. And we found it by accident, in one of the most inhospitable regions on Earth, because the wind had eroded just enough sandstone to expose the edge of a jaw, Everything else the Cretaceous produced, every alien lineage, every translucent skull, every impossible mouth, remains buried beneath the sand, or eroded into dust, or lost entirely to the long indifference of geological time. The animals we know are the ones we were lucky enough to stumble across. The animals we will never know outnumber them by orders of magnitude that no excavation will ever close. Number 4. Lascaux and the artists who painted in the dark. In September of 1940, 4 teenagers and a dog named Robot were walking through the wooded hills of the Dordogne region of southwestern France when the dog disappeared down a hole left by an uprooted tree. The boys widened the opening, lowered themselves into the dark, and dropped into a chamber no human had entered for 17,000 years. Their lamps caught movement on the walls, horses galloping, bulls the length of buses, stags with antlers branching across the ceiling in lines so confident they seemed to have been drawn moments before. The boys had stumbled into one of the greatest art galleries on Earth, sealed beneath a French hillside since the end of the Upper Paleolithic. The cave system at Lascaux contains nearly 6,000 figures. Animals, humans, and abstract signs spread across hundreds of meters of limestone walls and ceilings. Horses, aurochs, ibex, deer, bison, a single bear, and an enigmatic creature researchers call the unicorn. Some figures are small enough to cover with a hand. Others are immense. The largest bull in the Hall of the Bulls stretches 17 feet from nose to tail, rendered in a single continuous outline that no modern artist could improve. The pigments are vivid even now. Deep reds from hematite, charcoal blacks, yellow ochres ground from iron-rich clay, whites from calcite. The colors were mixed with animal fat and water, applied with brushes made of moss and animal hair, blown through hollow bird bones to create the soft gradients of a horse's flank or the shadow beneath a bull's belly. This was not graffiti. This was not the idle scratching of bored hunters waiting out a storm. The painters of Lascaux planned. They surveyed the cave, selected surfaces for their natural curvature, and built scaffolding to reach ceilings 12 feet above the floor. Sockets cut into the walls still hold the memory of timber beams that supported the painters as they worked. They carried stone lamps filled with rendered animal fat, wicks made of juniper, and labored for hours in air that grew thick with smoke and exhaled breath. They ground their pigments in shells. They mixed binders. They tested colors. They returned, generation after generation, to the same chambers, adding to the work of artists who had died centuries before they were born. And then there is what the flickering light revealed. In 2012, researchers studying the cave under controlled lamp conditions noticed something that no daylight photograph had ever captured. When viewed by the unsteady glow of a tallow flame, certain figures appeared to move. A horse painted with multiple overlapping legs seemed to gallop. A bison rendered with 2 sets of heads appeared to turn. A stag drawn in superimposed poses appeared to leap. The effect was not accidental. The artists had understood that flame is not steady, that shadows shift, that an image painted with deliberate redundancy could be animated by the lamp itself. They were not just painting animals. They were painting motion. They had discovered, 17,000 years before the invention of celluloid, the foundational principle of every animated film ever made. The implications are difficult to absorb. The people who created Lascaux had no agriculture, no pottery, no written language, no metal tools. They lived as their ancestors had lived for tens of thousands of years, hunting reindeer and horse across a glacial Europe that bore little resemblance to the landscape we know. And yet, they possessed the cognitive sophistication to plan multi-figure compositions across hundreds of meters of stone, to engineer scaffolding, to manufacture pigments from raw minerals, to develop spray painting techniques, and to anticipate the behavior of firelight on a curved wall. The gap between what we assumed Ice Age humans were capable of and what they actually produced is a chasm we are still trying to measure. The cave itself has been closed to the public since 1963. Human breath and body heat were destroying the pigments faster than they had degraded in 17 millennia of darkness. A replica now serves the tourists. The original chambers sit sealed beneath the Dordogne Hills, monitored by climate sensors, visited only by a handful of conservators a year. The horses still gallop in the dark. The bulls still face each other across the hall. The flames are gone, but the figures that the flames once animated remain on the walls, waiting for a light source that will never return. The artists are gone. Their names, their songs, their reasons for descending into that cave with lamps and pigments and scaffolding are gone. What remains is the proof that they were here, that they could see, and that they were already, in every way that matters, us. Number 3. The Denisovans. In 2010, geneticists at the Max Planck Institute for Evolutionary Anthropology in Leipzig published a finding that did something no discovery in the history of paleoanthropology had ever done before. They identified an entirely new species of human being without a skeleton, without a skull, without a face. They identified it from DNA alone. The physical evidence was almost insultingly small. A single fragment of finger bone. A pinky tip, no larger than a penny, recovered from the floor of Denisova Cave, a limestone hollow in the Altai Mountains of southern Siberia. The cave itself is unremarkable from the outside. A dark slit in a wooded hillside, cool and damp, dimly lit by whatever sunlight, reaches its mouth. Russian archaeologists had been excavating the chamber for years, recovering stone tools and animal bones from a sequence of sediment layers stretching back hundreds of thousands of years. The finger bone was found in a layer dated to roughly 50,000 years ago. It was assumed to be Neanderthal. It was sent for genetic analysis as routine confirmation. The genome that came back was not Neanderthal. It was not modern human. It was something else. The implications detonated across multiple fields simultaneously. A new species of human, distinct from Homo sapiens and distinct from Neanderthals, had been living across Asia within the time frame of recent prehistory, not millions of years ago, not in some unreachable evolutionary past, within the last 100,000 years. While our ancestors were painting horses on the walls of Lascaux, a different kind of human was walking through the forests of Siberia, leaving fingerprints in cave sediment that would not be read for another 50 millennia. They were named the Denisovans, after the cave that yielded their bone. To this day, that is essentially all we have. A handful of teeth, a jaw fragment recovered later from the Tibetan plateau. Almost nothing that would let us reconstruct a face. We do not know what they looked like. We do not know how tall they stood. We do not know the shape of their skulls or the structure of their hands. We know them only through the chemistry of their genes. Read backward from a sliver of bone smaller than a fingernail. But here is where the discovery becomes genuinely disturbing. The Denisovans did not stay in Denisova Cave. They did not stay in Siberia. The genetic evidence revealed that they ranged across an enormous expanse of Asia for hundreds of thousands of years, and that they did not vanish without leaving a trace. They left their trace inside us. Modern populations across Asia and the Pacific still carry Denisovan DNA in their genomes today. Melanesians, Aboriginal Australians, and the indigenous peoples of Papua New Guinea carry up to 5% Denisovan ancestry. Tibetan populations carry a smaller but specific signature. The interbreeding was not a single event. It was repeated, sustained, geographically widespread. Our species met theirs, and the two did not simply coexist. They merged. The Tibetan signature is the most unsettling of all. Tibetans live at altitudes above 13,000 feet, in oxygen-thin air that would induce altitude sickness, organ failure, and death in lowland populations within days. They survive because of a specific gene variant called EPAS1, which regulates how the body responds to low oxygen. That gene did not evolve in modern humans. It was inherited from the Denisovans, a vanished species that left no statue, no monument, no written word, gave the people of the Tibetan Plateau the biological key to inhabit the roof of the world. Every Tibetan herder driving yak across high pasture is breathing with the lungs of a ghost. The Denisovans also interbred with Neanderthals. A single individual recovered from the cave, a teenage girl who lived approximately 90,000 years ago, was found to have a Neanderthal mother and a Denisovan father, not a distant ancestor. A direct first-generation hybrid. Two separate human species walking the same landscape, raising a child together in a Siberian cave. The picture that emerges is not the clean evolutionary tree of older textbooks, with Homo sapiens rising alone toward the present. It is a tangled web of intersecting lineages, of multiple human species sharing the planet within evolutionary minutes of the present moment, exchanging genes, raising children, disappearing into each other. There were other kinds of people. They lived alongside us. They had families with us. And then, sometime in the last 50,000 years, every lineage except our own went silent. We do not know why. We do not know how. We know only that the Denisovans were here, and that fragments of them are still inside the bodies of millions of living people, still doing the work of keeping them alive at altitudes the rest of us cannot reach. The pinky bone sits in a laboratory in Leipzig. The species it belonged to has no face, and the cave in Siberia is still cool, still dim, still waiting to give up whatever else it has kept hidden in its sediment for the last 50,000 years. Number 2. The Antikythera mechanism, the ancient computer that should not exist. In October 1901, sponge divers working the waters off the small Greek island of Antikythera surfaced from a wreck site 60 meters below and reported something the archaeological world had never prepared for. Among the marble statues and bronze fittings of a Roman-era cargo ship that had foundered around the 1st century BCE, they recovered a corroded lump of metal and wood. It looked like nothing. A barnacled brick of greenish bronze fused into a fragment of waterlogged timber. It was catalogued, set aside, and largely forgotten for decades, while scholars focused on the more obviously valuable finds from the same wreck. The lump was a machine. Inside that unremarkable mass of corrosion, sealed for 2,000 years beneath the Aegean, was a device containing over 30 precision bronze gears arranged in three-dimensional configurations of staggering complexity. The mechanism, once housed in a wooden case, roughly the size of a shoebox, could predict solar and lunar eclipses decades into the future. It tracked the lunar cycle with astonishing accuracy, accounting even for the moon's irregular motion across the sky. It charted the positions of the known planets against the fixed stars. It marked the timing of the ancient Olympic Games. Dated to roughly 100 to 150 BCE, the device represents knowledge developed over centuries prior. Knowledge that should not have existed in the form it took. The gear teeth are as fine as those inside a wristwatch. Triangular, hand-cut, perfectly meshed. Some teeth measure barely over a millimeter across. The inscriptions covering the surviving plates, partially legible through X-ray tomography conducted by the Antikythera Mechanism Research Project beginning in 2005, describe astronomical events, calendar systems, and operating instructions for a user who is presumed to have understood what they were holding. The device was not a prototype. It was a finished instrument, produced by craftsmen who had clearly built such things before. But here is where the standard timeline of human technological development falls apart entirely. Nothing of comparable mechanical complexity appears again in the archaeological or historical record for over 1,000 years. Not in Rome, not in Byzantium, not in the Islamic Golden Age, which preserved and extended Greek astronomical knowledge in nearly every other respect. The next devices that approach the Antikythera mechanism's sophistication are the astronomical clocks built in European cathedrals beginning in the 14th century, more than 1400 years after a Greek craftsman cut the last tooth on the last gear of the device that ended up at the bottom of the sea. The history of analog computing, as it had been written, was pushed back by over a millennium in a single afternoon of laboratory analysis. The implications are difficult to absorb. A civilization possessed the engineering vocabulary required to build a hand-cranked planetary computer. Then, that vocabulary disappeared. The knowledge did not propagate. It did not survive in copies, in descendants, in derivative instruments scattered across the Mediterranean. As far as the archaeological record can tell us, the lineage that produced the Antikythera mechanism left no successors. The skill set required to design differential gearing, to model irregular celestial motion in bronze, to inscribe operating instructions in microscopic Greek lettering, vanished. It vanished so completely that for 19 centuries, no one knew it had ever existed. What makes this particularly unsettling is the implication of what was lost alongside it. The mechanism is too sophisticated to be a singular invention. It implies workshops, apprenticeships, earlier devices that taught its makers how to cut differential gears and calibrate eclipse cycles. It implies a tradition. And that tradition is gone. Every workshop that produced it, every craftsman who understood it, every text that documented it, all of it dissolved into the same Mediterranean silence that preserved the single surviving example only by accident, only because a ship sank in deep enough water to keep it hidden from the centuries that would have melted it down for scrap. The mechanism sits today in the National Archaeological Museum in Athens, displayed in fragments behind climate-controlled glass. The bronze is still green. The inscriptions are still half-legible. The gear teeth, where they survive, still mesh in. Patterns that took modern researchers, equipped with CT scanners and computer modeling, decades to reverse engineer. A device built by hand in a Greek workshop before the birth of the Roman Empire required the full apparatus of 21st century technology simply to be understood. And the question that lingers beneath the glass is the one no archaeologist can answer. If a civilization could build this, and the knowledge of how to build it could disappear so completely that the world forgot such things were possible, what else did they build that the sea did not preserve? Number 1. Göbekli Tepe, the temple that built civilization. In 1994, a German archaeologist named Klaus Schmidt arrived at a low, rounded hill in southeastern Turkey that local farmers had been plowing around for generations. Previous surveyors had glanced at the site, noted the scatter of broken limestone on the surface, and dismissed it as a medieval cemetery. Schmidt looked at the same stones and saw something else. Within hours of his first visit, he understood that the hill wasn't a hill. It was a structure. Something massive. Something deliberate. Something buried. What he uncovered over the following decades would dismantle the foundational assumption of human prehistory. Göbekli Tepe dates to approximately 9,600 BCE. The number requires a moment to absorb. It predates Stonehenge by roughly 6,000 years. It predates the Egyptian pyramids by 7,000 years. It predates the invention of pottery. It predates the wheel. It predates agriculture itself. When the first stones of Göbekli Tepe were raised, no human being on Earth had yet planted a domesticated crop or fired a clay pot. The builders were hunter-gatherers, nomadic bands, people whose entire material culture, by every model science had constructed, should have been incapable of producing what they produced. And what they produced is staggering. Massive T-shaped limestone pillars, some weighing up to 20 tons, some standing 18 feet tall, quarried from the surrounding bedrock, dragged across the landscape, raised upright, and arranged in circular enclosures up to 65 feet in diameter. The pillars are carved, not crudely, intricately. Foxes mid-stride along the flanks, snakes coiled in tight repeating patterns, scorpions frozen with their tails arched, vultures with outstretched wings, abstract human figures with folded arms and elongated bodies, faceless, watching. The reliefs are executed with a confidence that suggests not first attempts, but a tradition, a craft already mature when the chisels touched stone. There are no tools of the kind required to do this work. There are no quarry settlements, no permanent villages, no granaries, no domesticated animals, no signs of the agricultural infrastructure that every textbook insisted must precede monumental architecture. The model was simple and seemed unshakable. First, humans learned to farm. Farming produced surplus. Surplus produced settlement. Settlement produced hierarchy. Hierarchy produced religion. Religion, eventually, produced temples. Göbekli Tepe inverts the entire sequence. The site has no domestic structures, no hearths for cooking, no floors worn smooth by daily life, no refuse pits of the kind that accumulate around human habitation. Göbekli Tepe was not a place where people lived. It was a place where people gathered, a place they walked to from across the region, raised stones at, performed something at, and then walked away from. Schmidt called it the world's first temple. The implication is heavier than the term suggests. If hunter-gatherers built temples before they built farms, then the standard narrative of human civilization is backward. Religion did not emerge from settled life. Settled life may have emerged from religion. The need to feed the people who came to worship, to sustain the labor force that raised the pillars, may have been the pressure that drove the domestication of wheat in the hills just a few miles from the site, where the genetic ancestor of modern einkorn wheat still grows wild. Temples may have built civilization, not the other way around. And then, around 8000 BCE, the builders did something stranger than the building itself. They buried it. Deliberately, methodically, they filled the enclosures with earth and debris until the pillars disappeared beneath the soil, sealing whatever had happened there beneath the hill that farmers would later plow around for 10,000 years. Why they buried it, no one knows. What they were protecting it from, or protecting the world from, is a question the stones do not answer. Göbekli Tepe is still being excavated. Less than 10% of the site has been uncovered. Beneath the Turkish soil, the rest of the pillars wait, carved with reliefs no living eye has seen, raised by hands whose names and language and gods are gone, holding the answer to a question we are only beginning to know how to ask. If you want to see more videos like this, click the video on screen now and make sure to subscribe.